Good morning to all MAF11 students present at different centers today. Thanks very much for coming for class today. Tonga, Solomons, Kiribati, Tuvalu, Cento, students from Noda campus, right? Special welcome to you all for MAF11 for this semester. Let me introduce myself to you. My name is Avikesh Kumar, and I will be the one who will take up all the satellite class for MAF11 this semester. However, I am not the coordinator for the course. The coordinator for the course is Loriza Rafiq. I hope you have already got your course materials there with you. If you haven't got that, please check with your campus coordinators there. They should be able to help you out with that. Also, please try and do check with your campus coordinators about the timetable for your tutorials. You are supposed to have some tutorial classes at your different centers, so please check with your campus coordinator for the timetable for this course. Also, as I have said, for this course there are 4 course books that you need to have. It comes in a package, so if you have got it, there should be 4 course book and 1 INA book. We say internal assessment book. That is the most important one, reason being because it has got all your assignments, all the due dates, the format for the mid-semester test, the sample for a mid-semester paper, and the sample for the final exam as well. So please just go through your INA book very carefully. It also gives you the study schedule. Once I switch back to the document camera, I will show you where you can view all those things. Also important here is you log on to your Moodle. Right, Moodle page is also very important for this course. Any important information that needs to be conveyed to you from the course coordinator will be through the Moodle. So it's very important that you visit Moodle regularly as you find time for yourself. The Moodle page has got some weekly notes. Alright, the extra resource we say that you can also have on the Moodle. Moodle also have got a past year papers there, past mid-semester papers, and so on. So if you visit the Moodle on MAF11, you will come to see a lot of resourceful things for you that may be really helpful for the course. Now, what I was talking about is this book, right? The most important one, MAF11, it says Introduction and Assignments. That's the most important one, right? If we turn to this on page 8, right, it has got this sheet there. We say the study schedule page, right? So this is the most important one, page 8. Reason being is because it gives you different topics that needs to be covered in the respective week. Take for example, we have week 1, week 2, week 3, we are supposed to cover algebra, and that is how you should also plan your work throughout this semester. Likewise, week 4, 5, 6 you have functions and graph, then week 7 you have trigonometry, and also if you see here it says mid-semester test. Right, mid-semester test is also in week 7. I will talk about the assessment after this, right? And then you have your assignment due dates as well. You have assignment 1 due 24th April 2015. So this is the most important page that you need to follow very closely throughout the semester. If it says week 7, take for example, if it says trigonometry, that means in that particular week, week 7, you should be looking at the topic or the course book trigonometry, right? So the reason being is because you need to be in par with the coverage that we have in Lodala campus. Now, second important thing I want to show you is about the assessment, right? The assessment, since this is a DFL course for the regional students, right, you have DFL assignment 1 10%, assignment 2 10%, and mid-semester test 20%. So the first assessment that we'll be going through is your mid-semester test, which I have showed you previously in week 7. So it's a lot. As we proceed in the semester, maybe we'll try and put some extra resource for you to prepare for the mid-semester test paper. The sample for a mid-semester paper is also in the course book, also in the INA book, which you can try and look at that later. Now, also let me tell you one more important thing about the final exam. Coursework is 40%, final exam is 60%. In order for you to pass the final exam, you need to get 40 out of 100 in the final exam, right? You need to get 40 out of 100 in the final exam in order for you to pass the course. If you score less than 40, you ultimately fail the course, right? So even though if you have a coursework 40 out of 40 and then you get in the final exam 20 out of 100, you ultimately fail the course because you have not met one of the USP's policies for final exam, right? You need to get 40 out of 100 in the final exam. I will try and advise you on this later as we proceed in the course. Now, there are a lot of things we need to cover for today's class because if you look at the weekly schedule, it says week 1, week 2, week 3 we should be able to finish with algebra. And algebra, there are a lot of important things that you need to look at. And also just a personal advice, right? To understand the topic maths, right, you need to be really good in algebra. If you fail to understand algebra, you will have a lot of problems later in the course. If you are able to understand algebra, basic algebraic techniques, right, you should have a good time with MAF11. Now, any question, anyone, before I proceed with today's coverage, right? Any center, any question you would like to ask on what I have just said, right? If you have any questions, feel free to put up your question through the chat box. I will try and advise you on that, right? Any questions coming up, right? Since there is no question coming up, right, I will proceed through the coverage for today's class. Right now, if we look at course book 1, the first subtopic that we come across is on factorizing, right? Is on factorizing. The simple factorizing techniques that we are looking at is, the first one is common factor. The word itself, common factor, tells you we are looking for something that is common. Now, if you look at the first expression, you have x squared minus 6x. So there are only two terms. The first term is x squared, the second term is negative 6x. Now, common factor means common. Common means something that is same for each term. And if you clearly look, right, what is common is a x. So x squared, if you break x squared, you have x times x, because x squared is x times x. Then you have minus 6x. So clearly you can see that x is common, right? So if we put x outside, right, and in the bracket you write what is remaining. The remaining part is x minus 6, because I am taking these two x outside as a common term. So we get x into x minus 6, right? Likewise, second one, you have 4x squared minus 12. You don't have any x in this, so definitely x is not common. So let us look at the numbers we have. We have 4 and we have 12. 4, let's write 4 as 4x squared minus 12. So 12, we can have factors of 12 as 1 and 12, right? You can also have 2 and 6. You can also have 3 and 4. If I use 2 and 6 here, I will not be able to get anything common. So I cannot use 2 and 6, right? I can use 3 and 4 because I can also have a 4 there. So I will just put that as 3 times 4. And clearly you will see that 4 is common. So put 4 outside and the remaining part goes in the bracket, which is x squared minus 3. Now you can also, or you can always check whatever you have done is correct or not. The opposite of factorizing is expanding, right? Expanding and factorizing, they are opposite to each other. We have factorized, so to check we simply expand. 4 times x squared, you get 4x squared, and then 4 times negative 3, you get negative 12. So that means our factorization is correct for that particular question, right? Likewise, you have x cubed minus 4x squared, right? Now for this question, x squared is there, x cube, you can write x cube as x times x squared, because x cube is x times x squared. Then you have minus 4x squared. The reason why I'm writing like this is so that I can clearly see a common term, which is x squared there. So put x squared outside, and you have x minus 4. So that is the first factorization technique that we have looked at, which is called common factor. Right, so let's move on then now to the second one, the second factorization technique. Now sometimes we have a expression that is of the form ax squared plus bx plus c, right? So that's the form. We need to know how to change or how to factorize a expression of this form. So the rule is very simple. The rule is very simple. Look at the first term and the last term only. First and last term, right? Now x squared means there should be 2 factors, right? Quadratic means 2 factors. So since there are 2 factors, I'll put up 2 brackets. 1, 2. 2 factors. X squared. If you break x squared means what? It means x times x. So x in each bracket, right? That's done. Now you have negative 18. You have negative 18 as your last term. Look at the factors of negative 18. Factors of negative 18, let's say, is 1 and 18 you can have, 2 and 9 you can have, and you can also have 3 and 6, right? So these are the 3 possible factors for 18. However, one of them has to be negative because you have negative 18 there. Which one is negative? I will decide it later. Now, once you have identified the factors, what we do is this. Look at the middle term. You have 7 as your middle term. 7, right? 7 is your middle term. Which of these factor will add or subtract to give you 7? Let's look at 18. 1 and 18. 1 and 18. Can you add or subtract to get 7? No. So this is not the factor. 3 and 6. If you add 3 plus 6 is 9. If you minus 6 minus 3, you get 3. So this you cannot have 7, never. Right? However, you can have this 2 and 9. If you add or subtract, you can have 7. Right? Now here you have positive 7. Positive. Since this is positive, the bigger number we make it positive, the smaller number we make it negative, because negative 2 times 9 is 18. So you have minus 2 there and plus 9. Right? Now let us check. To check what we do is we multiply outside terms. Outside terms, x times 9, you have 9x, and then you multiply the inside term. Negative 2 times x, you get negative 2x. 9x minus 2x, you get 7x. 7x is your middle term. So that means we have done the factorization correctly. So this is the technique that you need to understand for this course. However, there may be some other techniques you have learned in your high school which is also correct, so we can also accept that answer as well. But for our satellite class, I will just stick to this method. But if you have some other techniques, no problem, you can go ahead using that, right? So next one, you have x squared minus 10x plus 9, x squared minus 10x plus 9. Now again we have two factors, 1, 2. X squared means x and x. Factors of 9, I'll just write it here. Factors of 9, how can you have 9? You can have 1 and 9, 3 and 3. The inside term there is 10. Can 3 plus 3 or 3 minus 3 will add up or subtract to give you 9 or 10? No. So this is out. The factors we're going to use is 1 and 9. But 1 has to be negative, 1 has to be positive, or vice versa. It's positive 9. Two positive numbers will never give you negative. So make it both negative, because you can also have negative 1 times negative 9 is 10. So both are just negative, negative 1, negative 9. And then you can check the way I have told you to check. This one. Now sometimes if there are 3 terms, you can find a common term. You have 2, 4 and 16. 2, 4 and 16. The common number will be 2. You can have 2 outside, then you have x squared minus 2x minus 8. And this part you can factorize as what I have shown you, right? So you'll have here 2 and you'll have 2 brackets for 2 terms, 1, 2, right? So I'll give you x here, I'll give you x. So you decide what are the factors of 8 you're going to use, right? So that one I just leave it to you, right, to complete that in your spare time. Then we have a case where you have nothing common, like 2, 5 and 3. Nothing is common between the 3 terms. So in this case, just the rule remains same. Since x squared, so 2 brackets, 1, 2. Break 2x squared. 2x squared means 2x times x. That's how you get 2x squared. And then look at factors of 3. Factors of 3 are 1 and 3. Now 1 and 3, 2 positive numbers, can that give you a negative number? No. So make it both negative, negative, negative. So you have negative 1, negative 3. Where to put negative 1, where to put negative 3, you have to decide using trial and error method, right? Let's say if I put negative 1 here and negative 3, say for instance, if I put like this, let's check. Cases such as this, it's very important that you check. So outside term you multiply. 2x times negative 3, you get negative 6x. Negative 1 times x, you get negative x. So this gives you negative 7x. Our middle term there is negative 5. That means the places we are putting the factor is not correct. So just change, right? So change now. So make this one to be negative 3 and this one to be negative 1. So if you check now, 2x times negative 1, you get negative 2x, right? Negative 3 times x, you get negative 3x, and if you add, you get negative 5x, which is our middle term. So this is what we say trial and error method, right? You identify the factors and then check where to put which factor to get to the answer. Likewise, this one, you have 5x squared minus 9x minus 2. So again, you'll have 2 factors, 1, 2. 5x squared will be 5x and x. Factors of negative 2, you have 1 and 2. but one will be negative, one will be positive. Decide which one will be negative, which one will be positive. So you try and complete that and then check on what I have told you how to check, right? So that's the second factorization technique that you have to know of, right? And then we have the last one, which is called difference of two squares. This you have been doing since form 4, so by now none of you should have any problem with difference of two squares. Difference of two squares means there are two terms and both are being squared. So if you factorize, you will get x minus y, and then you have x plus y. One will be negative, one will be positive. That's what I mean by difference of two squares, right? Take for example x squared minus 9. This first term is written as a square number. Second term is 9. So you need to change this term 9 to a square number. So how can you write 9? That will be x squared minus 9. You can write as 3 squared. So both are now written as a square number. So to factorize, you'll have x minus 3 and then you have x plus 3. Right? So that's the first one. Sometimes in a question you cannot apply difference of two squares directly because there may be a common term. Take for example this 3 and 27. 3 and 27. Right? There is a common term. Right? There is a common term. Anyone from any campus can let me know through the chat box what is the common term between 3 and 27. A common factor, that would be what? Any idea? Anyone from any information center? Amless, Solomons, right? Tonga, thank you for your response. Definitely it is 3. So 3 is a common term. We'll put 3 outside and then you have x squared minus 9. And then x squared minus 9, we have just done the factorization part, because we have said for x squared minus 9 you can write that as 3 into x squared minus 3 squared, and then you can complete that question, right? So that is on difference of two squares. And also sometimes you will not have a common term but you have two terms present. Our rule is same, right? This can be written as 9 can be written as 3x whole thing squared, because 3 squared is 9, x squared there. Minus 16 can be written as 4n over 10 squared. So this will be then 3x minus 4 over 10, and the other one will be 3x plus 4 over 10. So there are different factorization techniques that you have to know of for this course. So that was the discussion for unit 1.1, right? I hope you are able to understand, right? And if you have any question, then you can always reply through the chat box, right? But now I need to move to unit 1.2, which is on algebraic fraction, right? Algebraic fraction, it comes from the concept from what you have learned in class 8, right? It's about two or more fractions can be added or subtracted only if denominator is same. However, in primary school or in early secondary school, you were looking at how to add or subtract two fractions where both are in numbers. Let's say 1 over 2 plus 3 over 5. In our case, that we change it to a algebraic term where you have a variable x, right? So in this, so there are two techniques that you have to know of in order to do or simplify algebraic fractions. First one we say is cross multiply, right? That's the first technique that you have to know. And the second one is about lowest common denominator. Now, which technique to learn, right? Which one is the important one? I suggest both techniques are equally important, because the question itself will direct you on which technique to use. Take for example, for this question, you have two fractions and two different denominators. So the best technique that will work here is simply cross multiplication, and you multiply the denominator. So our denominator, it forms like this. You have x minus 2 and x minus 3. We never expand denominator, right? We don't expand denominator. We only expand and simplify numerator. Our numerator becomes like this. You had 3 there into this denominator x minus 3. You are taking it up, follow that arrow. So I'll put here x minus 3. Then you had minus 2 into this one, that side will give you x minus 2. So what we can do is simply expand the numerator, following the arrows there. 1, you have 3 times x, you'll get 3x minus 3 times 2 is 9. Then you have minus 2x, and then negative 2 times negative 2, you get positive 4. Be very mindful of that. However, denominator remains same as x minus 2 and x minus 3. So we don't expand denominator. So now to simplify numerator, just add or subtract the like terms, like 3x and negative 2x. These are the two like terms. 3x minus 2x, you get 1x. 3 minus 2 is 1. And then you have negative 9 plus 4, which is negative 5 over x minus 2 into x minus 3. That's done. That's how we simplify a algebraic expression using cross multiplication technique. Right? I will show you each of them. Just now I have showed you how to use cross multiplication, and then I will also look at how to use a lowest common denominator technique. Now, say for instance, this time you have 3 fractions. You have 2 over x plus 1, 3 over x minus 1, and 4 over x minus 1 whole thing squared. So for this question, cross multiplication technique will not be good to work with. Right? It will not be wise to use cross multiplication technique. So the technique for this question will change. Right? So we use lowest common denominator. You have x plus 1 there. Okay, you have x minus 1, you have x minus 1 whole thing squared. So I will just put here 2 over x plus 1 minus 3 over x minus 1 minus 4 over x minus 1 whole thing squared. It means 2 times. Take for example, if you look at x squared means what? X times x. X is repeating 2 times. Here you have x minus 1 whole thing squared. So it is repeating 2 times. X minus 1, x minus 1. Right? Now, compare the denominator. Right? Compare the denominator. You have x plus 1 there. Do you have x plus 1 here? No. So since there is no x plus 1, we put x plus 1. X plus 1. And then whatever you put in the denominator, same thing you put in the numerator as well. X plus 1. Do you have any x plus 1 there? No. So we put up a x plus 1. X plus 1. Set. So now we get here 2 over x plus 1 minus 3 into x plus 1 over x plus 1 x minus 1 and then you have minus 4 into x plus 1 over x minus 1, x minus 1, x plus 1. So now let's go one more step. Let's look at this fraction. You have x minus 1, 2x minus 1, x minus 1, x minus 1, 2 times. Here you have only one x minus 1. So what we do? Add 1. You have x minus 1. Put x minus 1 there. So x minus 1. And then also we'll put here x minus 1. Right? Now, we are putting only one x minus 1 because there was already one there present. If you look at this one, you have 2x minus 1 there, 2x minus 1 there, but here you don't have any. So here we put 2 times x minus 1, x minus 1. So your denominator, let's look at the denominator now. Common denominator is x plus 1, x minus 1, x minus 1. That was the reason why we have done that, so that our denominator is same. Now we just combine the numerator. You have 2 into x minus 1, x minus 1, minus 3 into x plus 1 into x minus 1, minus 4 into x plus 1. So from that difficult equation, we just looked at common denominator and we come to this. So now we just need to expand. So leave the 2 there, expand this. So these 2 remain same outside. X times x, you'll get x squared. Then you have negative 1x, then you have negative 1x, and then you have positive 1. This will be minus 3 into x squared minus 1x plus 1x minus 1, and then you have minus 4x minus 4 over, denominator is same, x plus 1, x minus 1, x minus 1. Right? So just simplify it now. You'll have 2 into x squared minus 1x minus 1x, you get minus 2x, and then you have plus 1, minus 3 into x squared minus x plus x cancels out, you get minus 1 there, and then you have minus 4x minus 4 over x plus 1, x minus 1. I can put a whole thing squared there. So further we expand that bracket, you'll have here 2x squared minus 4x plus 2. This will be minus 3x squared plus 3 minus 4x minus 4 over the denominator x plus 1, and then you have x minus 1 whole thing squared. And then just add the like terms. 2x squared minus x squared will get negative x squared, negative 4x minus 4x, and then you have 2 plus 3 minus 4. Just simplify it from there, right? So these are the 2 techniques that you have to know of in order for you to simplify algebraic expressions. Right? Maybe I'll give you a few seconds just to quickly copy it down, and I just hope that you will be able to simplify from there. Just add the like terms in the numerator. The denominator remains same. Right? This technique is what we say comparing denominators. The reason why we do this is so that our denominators are same, and then we can add or subtract fractions. Right? That's the main reason why we need to get a common denominator. Right? Can I move on? Right? Can I move on? Students at different centers? If okay, then just type in okay so that I can move on through the chat box, please. Right? Thank you, Lotoka. Solomons, Amles, Tonga. Right, Tuvalu, thank you. Right, set. So let's move on to the next one, which is unit 1.3. Unit 1.3 is on law of exponents. Again, this is something that you have been doing in your high school, so it should not be very difficult for you. The first one is, you should know what do you call this I, what do you call m and n. I is called the base, right? M and n is the power or indices, we say. The rule is, when the base is same, you can simply add the power. You have I to power m plus n. Just add the power. So take for example this, the base is same, 3 and 3, base is same, 3. So add the power, 2 plus 6, you get 8. Very simple. Likewise, you have I to power m divided by I to power n. The opposite of multiplication is division. So if multiplication we add, division we minus. So this will be 3 to power 2 minus 6, you will get negative 4. Yeah. Right. Then we have the third rule, which is says I to power m raised to power n. I to power n raised to power n. So in this, what we do is we simply multiply the two powers. You'll get I to power m n. Just multiply that. Likewise, for this one, you have 2 to power 3 times 4 is 12. Right. So try and do some more examples on each of the rule. Right. Now this, what it means is, there are two terms in the bracket. One is A, the second one is B, and both are raised to power m. So just separate it. You'll have A to power m, B to power m. Just separate it. Likewise here it will get 2 to power 5, x to power 5. Separate the terms in the bracket. Right, then you have I to power negative m. If you want to rewrite that, just take this whole term in the denominator. You have 1 over I to power m. In cases such as this is negative 6, right? Cases such as this, we don't take 2 up in the numerator. Numbers just live in the denominator. Only the variables we take. So you have 1 over 2. X is the variable. We take it up. And then change the sign for the power. This is negative 6, power becomes positive 6. And then the last rule that you have to know of is this one. This is what we say nth root of I. This means nth root of I. So to write that, the power of I there is 1, so that it becomes I to power. This becomes the denominator. This is with what we say fifth root of 300. So 300 there, so I'll put 300. Power was 1, so 1 over 5. This always forms the denominator. Alright, you have to know about how to simplify this type of expressions. Very simple, looks very difficult. It is all about common factorization techniques that we have learned. Right? There are two terms, 5 to power n, 4 times 5 to power n. Here you have 4 times. I can also put here times 1. Same thing. Now look at the two terms. What is common between them? The common term between them is 5 to power n, which I'll put outside. Left there will be 1, then you have plus, and then you have 4. So you get 5 to power n times 5 to power 1. Look at this, base is same. Base is same. What we can do, the power. Just add the power, you get 5 to power n plus 1. So initially the question looked very difficult. 5 to power n plus 4 times 5 to power n looked very difficult. But we just looked at one very simple technique, factorization technique, and then we come to this. Right? So same thing you can do for this. Right? Since it is times 5 there, I'll put times 1. Right? So try and do this question to get your answer is 6 to power k plus 2. Right? That's the answer you should get. Try and get that in your spare time. Just follow what I have done for the previous example, and then you should be able to get to that question. Right, that you can try that out in your spare time now. And then you have to also know how to factorize this type of expressions. Something similar you can also expect in your mid-semester test as well. So for this question here, you need to understand one thing. If I give you 2 to the power k times 2 to the power 1, you will say basis same, you add the power, you will get 2 to the power k plus 1. So this is given in this form. We need to go backwards, separate the terms. So this will give you 3 to the power 2 to the power k times 2 to the power 1 minus 4 over 2 to the power k. Right? Just a very simple thing I have done is I have separated that. 2 to the power k plus 1 can be written as 2 to the power k times 2 to the power 1. So now, simplification of algebraic expressions. Right? Compare the denominator. You have 2 to the power k there. You have 2 to the power k there. Same. You have 2 to the power 1. Do you have 2 to the power 1 here? No. So what we do is simply put 2 to the power 1 and then times 2 to the power 1 there. So now you'll get here 3 over 2 to the power k plus 1, because you can add the powers, basis same, minus 4 over 2 to the power k plus 1 as well, because basis same, you can add the power. Now denominator is same, which is 2 to the power k plus 1. Just also this one, 4 times 2 is 8. Sorry, 8. Just add to separate the numerator. 3 minus 8, you get negative 5. That's how simple that question was. It's all about breaking that part there to get to that answer. Right, so I have roughly about 10 minutes now, and I have one last part to cover for unit 1, which is unit 1.4. right? So I think 10 minutes should be enough, right? So unit 1.4 is on factor theorem, one of a very important yet very difficult for students to understand. Factor theorem. It says a polynomial. Polynomial means an expression that has higher powers of x. We'll have a factor x minus I. Any factor can be written as x minus I, or you can say x minus 1, x plus 2, x plus 3, x plus. Example of factor. If f of I is equal to 0. Now here you had x minus I. So x minus I equal to 0. If you solve for I, you'll get x equals to I. So once you get that, this I you substitute into the function f in place of x, and if you get 0, that means it is a factor. I will show you with one example on how to do this. To factorize a polynomial, long division can be used if I factor is known. If you know a factor, then only you can use long division. Right? What I mean by that is this. This is an example of a final exam paper. Factorize the expression completely. F of x equal to x cubed plus 3x squared minus x minus 1. Now at the moment, none of the factors are known. We don't know any of the factors. Right? We don't know any factors. So we do trial and error method to identify at least one factor. Right? Trial and error method. Let's say I'm using a factor as x equals to 1. I don't know whether this will work or not. Let me check. So x value is 1. So I'll put here f into 1 equals, in place of x I'll put 1. 1 cube plus 3 into 1 squared minus 1 minus 3. In place of x I am putting 1. And if you do in a calculator, you will see that you will get a 0. You get a 0. So we come to this. See, we come to this. It says f of I equal to 0. Means f of 1 equal to 0. If f of I is equal to 0, that means x minus 1 is a factor. So here we tried this with x equals to 1. So we need to write that as a factor. So this is x equal to 1. Take 1 on the other side. So you minus 1 both sides, minus 1, you'll get here x minus 1 equal to 0. So we can write that as this: x minus 1 is a factor since f of 1 equal to 0. Now in this is very important. You need to state that reason why you saying x minus 1 is a factor. We are saying x minus 1 is a factor because f of 1 equal to 0. So now we know about one factor. We know about one factor. So this brings me to this rule here, which I have said. To factorize a polynomial, long division can be used if a factor is known. So now we have identified one factor, which is x minus 1. So we can use long division now. So long division, you'll put here x minus 1, and what goes inside here is the polynomial that was given in the question, which is x cubed plus 3x squared minus 1x minus 3. Long division. So look for a term here that will multiply with x to give you x cubed, right? I need to get a x cubed there. What should I multiply with x to give you x cubed? Any suggestion? Any campus or any region? Any suggestion? What should I multiply here? What should I multiply here? Something I need to put. This times x should give you x cubed. Tonga, well done. X squared. So x squared times x, you get x cubed. Likewise, you have x squared times negative 1, you get negative 1x squared. And then we always minus. Always we minus. Right? Always we minus. So x cubed minus x cubed cancels out. 3x squared minus x squared. 3x, 3 minus 1, you get 4x squared. That's done. So now same thing again we do. Right? You find a term there that will multiply with x to give you 4x squared. What is that term? Right? It will be positive 4x. 4x times x, you get 4x squared. Sorry, I need to put this term down. You have minus 1x. And same thing there. 4 times negative 1, you get negative 4x. And then you minus it again. 4x squared minus 4x squared, 0. Negative 1 minus 4, you get 3x. And then bring the last term down, which is minus 3. So last term there will be positive 3, and you get 3x minus 3, and you get 0. You need to get a 0 there. If you don't get 0, that means you have done something wrong here. Right? If you get a 0, that means all your process, all your steps are correct. Very important. So now we get here is x minus 1, and then whatever we got, that one, x squared plus 4x plus 3. We have looked at how to factorize these two factors, right? Previously we have done that. You should get x plus 3, x plus 1. Right? So that's on that. Actually, I wanted to do one more question on this factor theorem, but unfortunately I don't have much time. So if you can try and do some more questions of this sort in your tutorial class. Just one last bit. just one last part to cover before you finish off, right? Sometimes you are given a expression of this form, x cube plus I cube, or x cube minus I cube. Let's say x cube minus 3 cube, and you are asked to factorize that. In this, you have to know about this form. You can't do anything without this form, right? If this is plus, the first term is plus, x plus I, and this is minus. If this is minus, this becomes minus, this becomes plus. So let's say if I give you a term, x cube plus 27. We cannot factorize at the moment. 27 you can write as 3 cube. So you have now x cube plus 3 cube, which will be equal to, for this you have x plus I. Our case is 3, so plus 3 into x squared minus I, which is 3x plus 3 squared, and you can put 3 squared as 9. Right? So that brings us to the end of our class today. I understand that we had a lot of things to cover, and I actually should do some more questions with you in the class, but please understand one thing, that weekly satellite sessions are only for 1 hour, so we don't have much time to do a lot of questions. I can only do one question and then move on, That's the reason why you have tutorials in your campus, right? The tutors are there, they are there to take classes. So very important that you attend your tutorials. Please check with your campus coordinator on where you are having your tutorial and what time it is, right? In the tutorials you should be able to do a lot of questions, right? Anything else you want to ask before I actually finish off? Solomon Allens, please upload this on the Moodle. Okay, I will try to do that. Savai, there is a comment, please can you send me some copies of lecture notes? Don't have course materials now, please. Keep on checking with your campus coordinator for your course materials. It should be at the campus by now. Can you repeat what you have said before? In the class we have started with overall discussion about the course, right? Oh, x cube plus 27 you said? Okay, this x cube plus 27, we cannot use common factor to factorize, right? We cannot use that form ix squared plus bx plus c. So in this case, x cube plus 27 you can write that as a cubic term, which is 3 cube. 3 cube is also 27. So x cube plus 3 cube, it follows this form, x cube plus I cube. So I just substituted the value of I, right? So very important that you know about this form, then only you'll be able to answer that question, right? So thank you students for MAF11. Let's hope to see you again next week at that same time, and please go over unit 2 before you come for the class next week, and try and do some questions from tutorial. If you find it difficult to understand, then let me know. I'll try and do some questions there with you. Thank you very much for coming for the class today. Hope to see you next week, right? That's it.